Yura, everyone. Hello. My name's Cameron Costello. I'm a Quandamooka man, the Nugi, Nunaka and Gurungal people of Moreton Bay. And I just want to pay respects to my elders, past, present, and want to just say that in my previous role, where I was CEO for our native title body and cultural heritage body, we managed national parks and native title lands where we have a significant population of koalas, and it was very much part of our thinking around caring for country, caring for culture, and part of that is caring for our fauna, which koalas are very important to us culturally, but important for the broader ecosystem as well. I want to pay my respects to and acknowledge the traditional owners of wherever you may be meeting today, wherever you're from. For me, I'm in the CBD of Brisbane City, so I acknowledge the Yagara and Turrbal people, and in our Jundai language we say Ngari Ninda Murumbriari Ngali Nilaba Wunjai Gurujin Jarjan Gulabulabu Yadnigu Yagara Turrbal, which means this sit down place where we're meeting on today. We gather, we acknowledge that the lands have been forever walked by the Yagara and Turrbal people. So wherever you are, acknowledge the traditional owners of the lands that you're on waters, and I wish everyone a great KoalaCollab series as we all join united First Nations communities, broader community, industry and government to make sure that we're doing our very best to ensure the conservation of these beautiful species. Thank you.
Good morning, everybody. It's an absolute pleasure to be here speaking for KoalaCollab today on behalf of a project team that has been working for months now around a series of different koala threats to try and mitigate any impact that we as people have on koalas that we're cohabiting with. So thank you for the welcome to country. I think it is always best when it comes from the people we're here to serve, and I'm really happy to be presenting on behalf of the whole team today. So I'm Sharon Rundle-Tearley, for those of you that haven't met me, and I work with a very talented team of committed people who work to protect people and planet. So our work spans across a range of different issues, and for 5 years we've been working very closely with Redland City Council, who've had a very large program running to actually protect koalas. Certainly from our early work, we actually managed to get some wins around a program that we actually trialled and then later on went to implement across the city over a 3.5-year period. And data showed from hospitals that there was a 40% reduction in deaths from dog attacks to koalas. So for us, a huge moment to actually celebrate, I think, for a team who've been really working on this space for quite some time to work with community to understand what they need and to help bring it forward. So I'm going to talk a little bit about the bigger project at play that we're now working for Department of Environment and Science and trying to roll out not only that leave it approach that we were working successfully with Redlands for that 3.5 years, but to look across other preventable things that humans can actually do to help protect koalas. So you can see the project aims here on screen. One of the keys to our approach and how we actually do it is to work with community and all of the stakeholders on ground. We get behind groups that are already at work and we help try and bring more strength to the work that they're already doing. We are not here to replace any of that. We trial different approaches, we help pass out approaches that we do and help ultimately find ways to engage better with community so that sometimes rather than simply telling people what to do, we can sell them on an idea and bring them on a journey with us to achieve the aim we need them to do while actually meeting needs that they actually want. And so that's where marketing sort of comes to the table with a little bit of a different perspective than just simple education approaches. So social marketing at Griffith have pioneered a process to explain how we do it. And we often train professionals and people to teach them how to bring a little bit more of the marketing or the sell into the process of what they are already, the fabulous work that they're already doing. So the process itself is very strategic. Get into people's hearts and minds, learn what they actually need to see, and then make it all happen. So I make that sound super, super simple, but the reality is it's a committed team delivering the hard yards and listening and learning from people and making adjustments when we get feedback, doing this quickly in real time and just trying to do it better and better again. So the process for us runs across 3 phases. We start with co-creation, so getting out there and learning what communities actually want to see. And from there, building it and testing it and making sure it's ready, and then ultimately letting people know that it's actually out there in that final phase that we call engage. So this is why we just call it the 3 simple steps, CBE. And there's a whole heap of marketing behind all of this. And if we ran it for the very first time, we can actually drop that into a sequence of how to actually start to roll that out. I won't be speaking about all of that today. What I will be doing is just showcasing a little bit every phase underway across different arms around koala threat mitigation. So I'll be sharing a bit of the team's progress, giving you an update of where we're currently at, and then finishing with the next step. So we're not by any means finished yet. So we're at work here for at least 1 year, but hoping to actually be working for years to come across the councils that are happy to work with us in whatever capacity works for them. So the team started with a lot of learning work. We have surveyed 2,500 Queensland residents, so South East Queensland people. And you can see on the screen there just the grey and white sort of like list showing where the survey responses have already come in from. This is our baseline. This is going to be our early measure of where the starting state was, so that we can start to look back across the efforts that are being implemented by our team, but also by councils themselves. And so next to that little table, you can actually see the first piece of science that has come out of this project, led by Aaron Chazinski at University of Queensland. He ran a review and worked with councils to understand what strategies are already in play. So what councils are currently doing. And that's important for us because we need to understand where different levels are actually at so that we can start to track for any form of success, what's starting to actually cut through. Our team have been out in community working with the local government areas who are happy to work with us. We've been meeting, we have proposals to write, a lot of work to actually do to help kickstart work in more spaces, but work is already well and truly underway in some spaces. And so some of you may be in the room where you already know and are actually working with us. And from us to you, thank you, because it's making a lot of great stuff happen already in such a short space of time. Our team have been out co-designing with community, learning what it is that they want to see. And I'll show you a few of those learnings next and shortly. And finally, one of the other things we've been doing is working with Department of Environment and Science to look at the data. So on screen there, you can actually see koala hospital reported data. Now, obviously not all koala deaths get reported, but some and many do. And what you can see coloured in there is the map that our team are now using because we know where the attacks from dogs are happening most. And so starting to localise our effort, both in who we go out to actually talk to, so where we're running co-design, where we're starting to run the advertising work to actually let people know there are training options available, and actually starting that whole process of talking to the people who need to hear from us the most without telling them necessarily and making them feel bad about why we're actually reaching out to them. So the team have been testing different approaches to message community around koalas. We know through the survey data that there's a limited understanding of what to do. People don't know the signs for a koala looking sick. They don't know where to call, and they certainly don't know some of the many actions that they can actually take. So already significant data is in hand, and soon we'll be reaching out to councils with the learnings we have for their local areas to start sharing that first starting point data. But you can see here some feedback around Redlands' work, and our work with Redlands has been ongoing. We've evaluated their campaign for 3 years now, watching and tracking and seeing what works, watching them listen and learn and respond to the community feedback, and it's been a fantastic partnership over time. They're very, very good at taking on community views and trying to iterate the thinking and keep the process actually moving forward. So this year, they're showing really clear, actionable tips, and this is something community had been calling for. So you can see it's something community loves. But sometimes they're just not so happy with the Bachelor campaign. And this is a finding we're seeing across some of the work. There's a real fine balance between being real and sharing real koala stories, but making sure that it's not so serious, because otherwise sometimes they actually tell us it's not engaging enough. It's not capturing our attention. It's not drawing the eye. Now, as a marketer, that's important. Like I've been trained, we have to cut through the clutter. So less is more, and very clear, memorable things that people can take away are what we're trying to build and implement and push out every day. We've also been testing the early work that we shared with the local government areas at the initiation of this project. So checking the messaging, seeing what works, learning from it, and also running the testing through the online space to watch what people do. Because while I can ask people what they think, it's when they actually do something and act that I really know we've actually got cut through. What they do love about our campaign is the colours. It's so Australian. And that's a good thing if you think about it, as we make an association here for this iconic creature that we are here to try and help rebuild stocks of. We want these creatures. They bring value, like economic value to housing. They bring tourism. So the more we can quantify this and teach people that, the stronger we're actually going to be. People are telling us they want very clear understanding of what to do. So keep telling us, give us ideas around the threats and the actions we can actually take. And once again, consistent with Redland's feedback, don't be too lighthearted. So we've got a bit of a tightrope to walk to get that balance right. And pleasing everyone is not always something that we can actually do. Now, the survey data, when you get 2,500 people, you can start to actually break it down, and you can start to understand the different types of people you're actually reaching out to. In our survey, we can actually see a very committed group and quite a high group responding to this survey, which is not entirely surprising given the topic, koalas. They're activists. They're very keen to protect and make sure that koalas stay living with us and we coexist with them. So they've got very strong beliefs around koalas, and somehow some of their behaviours don't necessarily match how they actually think. So here, we've called this person Helen. She is a dog, Molly. She lets Molly run off leash. She actually does that because she believes Molly's going to come back every time she's called. And so she thinks she's fine because she's actually got a dog who's safe and is actually coming back to her. So it's interesting because we could possibly start to move the way Helen thinks, because she is a role model. She's an activist. She's very concerned about koalas and she's here to protect and serve them. So we need her to start role modeling leash behaviour so that other dog owners start following her lead. And these are the types of strategies and insights we're starting to see as we dig deep into this data and start to work on the future messaging we can now start to bring to bear, where we're actually talking to women who are aged 45 or 55 and above, and going forward, making sure that they're seeing people like them and we're giving them the actions they can take that are going to help bring other members of the community forward with them. If we look to one of our other person types, we have Maddie with her dog Frankie. She believes in dog training and she thinks it's actually the right thing to do. She has no understanding that dogs can actually harm, maim, kill koalas. So there's a basic awareness job to do in the younger age cohort. We can work with them to teach them from that data that we now have, dog attacks can and do happen. So again, she's willing to train and we could actually bring her on board into that whole notion of training for the skill of koala aversion. So this is the beauty of the persona work. It is pretty much hot off press. It's just been coming through in the last days, and we'll still get refined a bit further with time as we dig deeper to understand more with the data from that survey that we actually have. We'll be able to tell council areas what we can see already from our data across their regions as we keep pushing forward. So we've been working very hard on the co-creation phase to continue to learn, and we've learned a lot. We're dealing with different regions, different areas. We have domestic dogs, wild dogs. There is so much more work for our team to now do to actually understand all of this and the wider set of actions that community can actually take. And that will be the work that's ongoing now across the next year to come as we keep pushing forward. But for now, there are things that we are already acting on and are actually doing. Our koala awareness work has been pushed forward with the initial ideas and starting to roll those out through and into community. We have some councils asking us for clear plans, other councils who are already working with our messaging and starting to push it out through their channels. And coming off press today, a 3.5-minute narrative about the actions that community can take. A 10-year-old girl who loves koalas and her actions cause others to act. So that'll be coming through, and all of these things together will start to look like campaigns that get rolled out in different local government areas in the ways that work for their councils across the work that we can actually do. Our team have actually been running the Wildlife Watcher channel for quite some time now. And you can see here, we already have a following built, we have substantial reach, and week on week, I am seeing significant engagement across the postings, and I'm watching these numbers just rise as our team are now resourced to do a lot more of this. And this afternoon, we'll be out actually running a Facebook Live session with the RSPCA hospital team, who are kind enough to share one koala story with us. So it's our way of starting to raise awareness for koalas, the threats that they face, and importantly, the actions that community can actually take. You can see across the work that we've been doing now, the pickup that is starting to come through. As a following gets built, people start talking for us. And you can see on this slide, the ABC News has been pushing this out through their channels. And that's how some of those really big numbers start to actually come through. And it is great to see community responding to, talking about, and actually caring for koalas with the actions they can actually take. So talking to people, listening to them, learning, and actually continuing to understand what other stories we can put out is such a big part of the work that we're doing. Here we have featured some of the work that Logan City Council is doing, where they've worked with our team around the images and the messaging already built, and they've taken steps even further. I mean, what a great idea, giving people the information that they can put into their glove box. So rather than feeling like they have to actually remember, they've got it at hand to pull it out at the point in time when they need it. They see a koala crossing a road who actually needs our help. Department of Environment and Science have been running some message testing, and they've been comparing and contrasting different approaches. And you can see here how the data starts to teach us which forms people are following, so which ones they like the most, share the most, and how they actually feel about it and respond in response to actually what we put up. So these are great approaches we can actually use to actually understand what we should be doing more of. And I just wanted to show you that to give you a sense. And then finally, there's our Leave It program, already out in some communities. So we're actually promoting actively in the Redland City Council area, and we're running some trial work in the Moreton Bay Regional Council area. So working with community members, we have events coming and planned, and actually literally starting to actually raise awareness for dog training wherever we actually go. So join us, follow us. You could actually literally get access to our Live, Laugh, Bark newsletter and start to follow what's actually happening as it comes through. So our way of engaging with the community around their favourite family members and making sure that dogs are enriched, well-trained, and including that koala aversion in a whole package of training activities and exercises that we actually do. Because our team don't just work on areas like dogs, we actually do work on cats too. Our actual social media channel is called Furry Friends. You will see a huge dog emphasis here, but there is cat stuff across the time and the project space too. And again, the following is growing week on week. Our reach is already substantial and high. We've reached more than 250,000 Australians. So not all of them are in Queensland. You can see other pockets and areas following our work too. But most of it here, it's local. So talking to people on a daily, weekly basis about their pets, getting feedback, creating more connections, and working out there with community. And then finally, events are actually also planned. And these are just simply aiming to bring community together, but making sure that we actually have at the core the serious side of what we're here to do. And so raising awareness for dog training, making sure that the community starts to learn more about what dogs are capable of so that we can train for them to actually avoid wildlife, including our koalas. So our first Dog Fest will be held down at the Redland City Council area on the 14th of November. And you can see the beginnings of all of the things coming to life as we're starting to actually market for the event, bring the stall holders together, and importantly, create the run schedule of training and other activities that talks that people can come and actually see. So Dog Fest is something that community loves. When we ran the first one back in 2017, people in community continued to ask us for 3 years, when was Dog Fest coming back? We can run a further couple of Dog Fests across the life of this project this year. So we hope this is the first of a few festivals to actually come. So that's a snapshot of the work that our team have been up to, which is a lot. And so we already have efforts rolling out through some of the councils, and we're about to commence work in council areas like Somerset, Scenic Rim, and get back to the other councils who are looking to actually partner up with us. So that's just a tiny bit from me on behalf of a whole team to give you a sense of what our work is aiming to do. Increase awareness for the threats that koala face, help people understand the actions they can actually take, including getting their dogs trained and sleeping inside at night. So just a little bit of the lot that we're up to. Thanks for having me. And if you have any questions, please go ahead and ask.
All right. First of all, quick apologies, folks. We've had a little bit of an IT issue, so you won't be getting the dulcet tones of Jeff Lundy Jenkins. I'm stepping in for him temporarily. I've got a couple of questions in here. Wanda's talking about dog training. Look, I think I'll actually answer that. The short version is in theory, yes, any animal can be trained. In terms of what that takes, that's more of a question of having every dog owner involved, and that's where Sharon's team's work is critical in bringing everyone to the table and start talking about, getting everyone involved. Dog species, it doesn't really make a difference as to what species the dog is. They can be trained. Some have require a bit more effort than others, but yeah, there's not a species particular barrier there. Paola's got a question regarding feral cats. Sharon, we don't really deal with feral cats directly in this, do we?
Not in this project, Brent, but members of our team, Dr. Patricia David and Bo Pang, have worked across feral cats and wildlife, and we do understand approaches that can actually be taken to work in that space too. So they would be very happy to have a conversation with you offline.
Yep, beautiful. And Renee's got a question regarding Facebook links and names again. Sorry, I came in a little bit late, so I can't really answer that question. We will see what we can do with that, though.
We will figure out how to get a copy of all of the slide deck out and make sure it's all available so you can see it. But you can follow Furry Friends Oz and Wildlife Watcher already, or you could just email me and I'll pass out some direct links for you as well.
Yep. Dr. Ann Smith is talking about official if noosa councils included in your work. I believe we did talk to noosa, Sharon?
We have got an initial conversation held with noosa where I think they've indicated they didn't want to work with us this year, but that doesn't mean we're not open to reopening that conversation back up. Whereas Sunshine Coast has actually asked direct for a proposal. So noosa was in initial conversations, but when we followed up, we got a no.
Yeah, and the big thing with that is we've got some really different time restraints. So for a lot of the councils, and this has been noticed with our work in general, it's just in terms of timing. A lot of councils we've come to them and they've said, look, we're really interested in being engaged, and same with noosa, but in terms of timing, it would take too long for us to go through the mutual approvals process, and they prefer this year to roll out what they've got and then keep a close eye on what happens down the track. And we're really keen to engage and work with anyone, but we're not going to force anyone to work with us. It has to be a mutually beneficial and mutually agreed approach to all of this. Right. Okay, now, don't seem to have too many more questions. What I might do is we might actually call an early end to this session, so we can work a little bit more on some of our IT issues on my end, and we'll be back with you very, very soon. Okay, apologies for that, folks. So we'll start again. Lyndall's a wildlife biologist and genomics researcher at University of Queensland, recently submitted a PhD thesis involving the effect of chlamydia on male koala fertility. During her PhD, she developed a rapid point-of-care lamp test for detection of chlamydia in koalas. So this technology has been incorporated into all wildlife hospitals in South East Queensland, Northern New South Wales and South Australia as a rapid in-clinic diagnostic tool. And look, as a personal comment, I can say it's absolutely brilliant for us out here at Moggle. She's previously occupied the role of senior scientist and project manager within the private sector, veterinary pathology and biotechnology industries. She's got a postgraduate degree of Master in Science in Agriculture. specialising in molecular biology and quantitative genetics. She has extensive experience in the development and implementation of molecular diagnostic assays within various animal industries. Over to you, Lyndall.
Thanks, Brent. Good morning, all. Thank you very much for joining us, well, joining me in this wonderful seminar series. As Brent explained, I'm going to be talking about development of diagnostics for the detection of pathogens in koalas. So you notice I've titled this as detection of pathogens. We all know that chlamydia is the leading sort of disease incurring pathogen in koalas. But through our research, we've actually detected alternate pathogens that may or may not be clinically relevant to koalas and yet to be sort of investigated. So how this all began, Steve Johnston, Associate Professor Steve Johnston of UQ, secured a grant looking at investigating the pathology, incidence and management of chlamydiosis in the male koala. So we knew, because males have not had as much attention as the females, and we all know it takes two to tango. So with this very novel project, sample collection began, and we undertook sort of screening of different sample types that we collected for the project, and sort of realizing that we need to be able to find a really reliable method for detection of chlamydia. And nowadays the gold standard is actually molecular detection of chlamydia. Previous methods of cell culture and so forth, they're very labor intensive. They're accurate, but molecular detection of chlamydia is the leading method for detection. Of course, it won't give an indication of disease status. It will give you an indication of the presence or absence of chlamydia within your sample. So this was a 4-year project spanning over 2013 to 2017. Within this project, Steve actually offered if I wanted to undertake my PhD based on the data that I was going to be generating as research assistant on this project. So this is how it's all begun. So So because we decided that molecular tests are going to be the gold standard for detection in our sample collection, we were collecting tissue samples, swab samples, and because we're concentrating on males, collecting semen as well. So being able to find an easy method to screen these samples was going to be beneficial. So I started scouring the literature, looking for suitable assays that we could potentially use and incorporate for screening our samples. So there was one thing that jumped out at me when I started searching how many different chlamydia detection assays were actually out there in the literature. They all have merit in their own right, but when it comes to standardization of testing, it did let down a little bit, and non-standardized methods does make it a little bit difficult for comparison. Even though all the assays were detecting chlamydia, they were targeting different genes. So I thought this would be a little bit of an issue because coming from the private sector, standardization in tests is extremely important. So therefore, I set about developing a real-time multiplex assay that could be used and possibly standardise testing within our South East Queensland hospitals. The development of this real-time PCR assay consisted of developing 2 multiplex panels. So each multiplex panel could detect multiple pathogens from one tube. So, of course, multiplex panel 1 was for detection of chlamydia in general, every strain of chlamydia that is present. Someone's just raised their hand. And of course, we decided why limit ourselves? If we can do a multiplex panel, why limit ourselves to just chlamydia? Let's put in some mycoplasma and ureaplasma. You just don't know what's going to pop up. So based on human modelling sort of projects, studies, mycoplasma and ureaplasma sort of go hand in hand in fertility project studies with humans. So we thought we'll put them in, never know what will happen, see what sort of incidents, if at all. And of course, in multiplex panel 1, we have our housekeeping gene for beta-actin. That confirms whether there's host DNA within that sample. And then you probably ask why we have 2 multiplex panels. So the first one is actually for detection of the pathogen. It doesn't speciate it. It just says yes or no, chlamydia is present or mycoplasma ureaplasma. So multiplex panel 2 is actually speciating chlamydia if it is present in the sample. And it's also a validation of the results that you see in multiplex 1, sorry. So we targeted UMP gene for Chlamydia pecorum and Chlamydia pneumoniae, and also thought to ourselves, what other pathogen could we include that would be relevant and informative to clinics or even zoos? So that's where we came across, included Bordetella within that panel. So Chlamydia pecorum, we made that one quantitative. I actually developed the quantitation from scratch, the standard curve used for the quantitation. I developed that from scratch using cell culture quantitation. So there was no extrapolation of nucleotides or anything like that. It was actually made from scratch and developed that way and validated. So then we had our 2 panels, and we were ready. It was all validated. Sensitivity and specificity was determined, and I was ready to start processing the thousands of samples that we had started collecting. So tissue samples were the big one, and then the mammoth amount of swabs as well that we collected. So speaking of the standard curve for the Chlamydia pecorum, what you see on the screen there is actually the standard curve run on the actual real-time PCR, and it gives you the limit of detection as well. So the cycling threshold, which is actually the number of PCR cycles it takes to detect a certain amount. So the lower the cycling threshold, the more chlamydia that is actually present in your sample. So the level of detection for our PCR assay in the multiplex was down to 74 infectious forming units per mil. So it's quite sensitive. 74 IFU per mil for a sample. You could say that's you're detecting chlamydial fragments at that stage, and non-clinical and potentially non-infectious. So we had collected all these samples and we'd PCR'd them, and we were at a stage where we could start looking at some statistics, at some epidemiology, and what sort of prevalence we've got that we could actually see happening. So at this stage, the wildlife hospitals, Currumbin and Australia Zoo, and who else is there? Moggle, RSPCA, I think that was a little bit after their time. I was screening all their swab samples on a weekly basis on the proviso that I could actually use the data for this research project, and in a bonus, they get their koala swabs tested for free. So they're getting actual quantitative results, and because all the main wildlife hospitals were using it, there was a standardized level across the board, across the hospitals, that was really important, especially when there's transfer and transport of animals between hospitals due to space issues, housing issues, things like that. Then everyone could compare the same test across the board. So as you can see, Chlamydia pecorum, of course, the most prevalent pathogen or chlamydia that we actually detected. And you could see, I'm just clicking on, see what sort of results we got there. So between the conjunctival and urogenital swabs, you know, we're looking, especially urogenital swabs, we're looking at about 74% infection rate detected from urogenital swabs, which is actually quite high. Compare it to the females, we got 31%. So there was quite a big difference there. Chlamydia pneumoniae was not detected once, and there was no prevalence whatsoever. So this actually sort of goes against what's been sort of reported in studies previously. So that was extremely interesting. And then to include mycoplasma and ureaplasma as well. So what was interesting is we started detecting mycoplasma within our samples. So albeit it was low, potentially could be environmental, but we were still getting detection. And then there was also that one urea semen sample that was ureaplasma positive. So that was a little bit of a shock. So we're still sort of investigating further for those discoveries. And yes, it was a while ago, but we're still sort of we've done some sequencing and made some interesting sort of revelations for that, which will soon be made public. So, and then we're further, of course, because we were concentrating on males for this project, we wanted to go a little bit further and looking at epidemiology of the different regions, comparing between peri-urban regions and rural regions as well. And sort of what you see, those tables there, the sort of prevalence rate of chlamydia detection between swabs and semen in koalas. So, and we also started reporting on percent of sort of clinical cases, clinical disease cases as well. So again, the sort of the rural diseases there, and sort of the symptoms are being shown, which brings me to my next slide. Next slide. There we go. And actually having a look, comparing sort of in chlamydia infection versus actual clinical signs of disease. So what we found in sort of swabs was really quite interesting. So the upper quartile, we've got animals there that are showing no clinical signs of disease, but have a high load of infection. So this could possibly indicate new infection, sort of, yeah, hasn't quite progressed to the pathology side. And those results pretty much matched with our semen samples as well. So while we were, it was all good and well running these, running the multiplex PCR for all the swabs and everything, this was not going to be a sustainable diagnostic method for going into the future. The money was going to run out at some stage. So having to think of something a little bit further, a point of care test that could potentially be implemented easily into hospitals that was going to be accurate, easy to sample preparation, and for non-lab people being able to use it readily was an important factor. So this is where the point of care diagnostic test for chlamydia pecorum on the genie, which is one I have prepared earlier, so you can see how tiny it is, sort of came out mainly from my PhD. So at my confirmation, it was suggested that why don't you think of this LAMP method on the genie and how easily it could be incorporated. So therefore, we set aside to actually develop a test, a point of care test based on loop-mediated isothermal amplification. Yes, that is an absolute mouthful, but in short, it's actually just a molecular diagnostic test that can be done in the field. So there's a couple of different methods that you can use for LAMP. There's actually a colorimetric detection method, or the real-time fluorescence method, which is what you can use on the genie. So the big advantages of LAMP is that it's such a simple and rapid protocol. You can get on-the-spot pathogen detection, pathogen diagnosis. In the case of the Chlamydia pecorum test, you get a result between taking the sample and getting a result within 20 minutes. So there's high sensitivity and high specificity, minimal sample preparation. There are a couple of different methods, but based on this is a point of care test, we want something with as least amount of steps for preparation as possible. One of the big disadvantages, if you want to use the Genie for the point of care test, it's that initial outlay for the Genie is quite costly. But in the grand scheme of things, this is something that you can keep into the future and potentially introduce or validate additional pathogens targeting different species of animals. So actually using the Genie for Chlamydia pecorum detection, the simple sample template preparation is just by putting a swab into a tube, adding some potassium hydroxide, giving it a shake, and it's ready to use. So the buffer that's remaining in the tube, you just take a sample of that, pop it into the tube, add the primers, which is what targets Chlamydia pecorum, and then some enzyme, and pop it into the Genie, and away you go. It's as simple as that. So the guys that are using it in the hospital now, takes them less than 5 minutes to prepare a sample to pop into the Genie. So just some background on how we developed and validated level of detection. You'll see that it's a little bit lower than actually the multiplex PCR. LAMP actually has a higher threshold for inhibitors that may be present on your sample than PCR. So it's a really robust method that can be used in the field by ecologists or even within the hospitals. So we've got level of detection down to about 44 IFU per mil. So, and just some C. pecorum specificity of the LAMP test. We had no cross-reactivity with any other pathogens that may be present, and we just threw in a whole screen, a whole heap of different pathogens, not just koala specific, and there was no cross-reactivity whatsoever. So pretty much as sort of Brent outlined, the Genie, the C. pecorum test has now been introduced as an in-clinic diagnostic tool into virtually all the wildlife hospitals that I know of. Down into New South Wales now, I understand Port Macquarie are now using the assay as well, and we're currently working up the assay for detection in other sample types, not just swabs. So using the application, it just rapidly and accurately assesses hospitalized koalas, and it does give diagnostically and for the welfare of the animal, or the for therapeutic treatment decisions, everything has now been sped up. Instead of waiting for a 7-day turnaround for results from a diagnostic lab, they can get results in 20 minutes. So a big point is that this test allows immediate application of appropriate therapeutic interventions and faster release times of koalas when assessing koalas post-treatment. So this is being a big key, being able to get them treated and released as soon as possible. So as I mentioned, we have also worked up assays, LAMP assays for a few other koala-specific pathogens as well. They're not used quite as commonplace, but we're looking at pneumonia. I've developed assays and validated assays for Bordetella, Klebsiella, oxytosa, and pneumonia as well. And then in my spare time, I've also developed a point-of-care test for detection of hendrovirus in horses. I know not koala-specific, but one of the most challenging sort of assays I've had to sort of to develop due to the biosafety level of the pathogen. So thank you very much for listening. I really don't have too much more to add in this sort of forum, but please feel free to ask any questions.
Alrighty, thank you very much, Lyndall. So we've got a couple of questions in here. The question is, can the detection test be used in the field when it comes to koala rescues? Actually, I can answer that one. Generally, Jason, we'll be looking for any koala that needs to be rescued. We'd be wanting them to go to a primary point of care, which is Australia Zoo, RSPCA, Currumbin, Endeavour Vet Ecology, where there are those facilities. So if an animal needs to be rescued, it should be going to have a full assessment by a vet, and then absolutely that will happen. Paul, this one's for you, Lyndall. Paul asks, does your test detect pathogens in koalas that have been vaccinated?
Yes.
Yep.
Yep.
Well, easy one. Kathleen has asked, where are we? Sorry. Collecting koala scats. Can you test scats for pecorum?
We are actually halfway, 3/4 of the way through developing the protocol. We're actually doing quite well because it's been a real challenge because of all the tannins and so forth within koala scats. Trying to develop a sample preparation method has been a massive challenge, but in sort of collaboration with one of the students, intern vet, well, she's not an intern anymore, down at Currumbin, we're developing a method now and we're very close to finishing that off. So being able to screen for chlamydia still in clinic using a non-invasive method has been high on our list of priorities, and we're getting close to getting that finished, so to speak. But it has been a challenge, that one. So
beautiful. Well, that goes partly the way to answer Vanda's question regarding testing wild koalas. In general, like we'd much prefer to be able to test through scat than actually catching an animal. You've got, even though we've got a lot of people that are capable, the cost and the effort far exceeds all our combined resources if we went around and caught every animal. Whereas if we can go through and test the scats, a really good way to focus and make sure that we get the best impact for what is in the end. There is a finite amount of resources, so that scat side of stuff is a massively exciting future expansion of that.
Oh, I'm glad we're all on the same page then, because that was first and foremost for me, is that, yes, we've developed this test. It's great for, in clinic using swabs and things like that. But, non-invasive testing is really, really quite high on the list. And, developing a method, a sample preparation method, which is the challenge, not the actual running on the test, was made as a priority. So we're getting close. We're getting close. So we'll definitely let everyone know when we're ready to go. So,
okay. Then a follow-up question from Vanda: how do you find which koala pooped? Once again, that would be just through a survey process. So you'd survey an area, and you might survey a large area. You'd identify which areas have the highest concentrations, where you could do the most good, and then you go through and you target specific animals in there. So initially, it'd be a very large-scale, broad look, and then you'd narrow that down. But we're happy to talk about that in more detail. And we're coming up towards the end. Thank you very much, Lyndall. It was really awesome to see an opportunity for you to get your research out, even though everyone in the hospital network knows about it. I think we've.
Good morning, everyone, and welcome back for the third presentation of this morning's KoalaCollab Conference event. The third presentation this morning will be given by Associate Professor Steve Johnston. Steve's presentation's in relation to the Living Koala Genome Bank project. Steve teaches animal reproduction to applied science and science undergraduate and postgraduate students at the University of Queensland. He's a zoologist that specialises in the area of reproductive biology in a broad diversity of species, ranging from prawns right up to tigers, but with a main focus on Australian mammals. Steve has published 259 scientific works in basic and applied science disciplines, including reproductive anatomy, physiology and behaviour. He has over 100 koala peer-reviewed publications, and he was the first person in the world to produce a pouch young following artificial insemination in a marsupial, a task that he and the team have now carried out successfully in koalas a total of 34 times. Steve is also a specialist in cryopreservation of marsupial spermatozoa, and in the assessment of sperm DNA fragmentation, including human and domestic animal spermatozoa. His recent research interest and grant success includes studies aimed at better understanding of the effect of chlamydia on male koala reproduction, heat stress in koalas, sociobiology of koalas, genetic and reproductive management of koalas, captive wombat reproduction, and echidna captive breeding, crocodile artificial insemination, and prawn aquaculture. So we thank Steve for joining us this morning and look forward to his presentation on the Living Koala Genome Bank.
Thank you very much, Jeff, and thank you for the introduction and also for the opportunity to speak to you today. On behalf of our research team, I would like to outline basically our concept that we've called the Living Koala Genome Bank, which was in fact a successful recipient of an Advanced Queensland Innovation Partnership grant. Unfortunately, over recent years, rightly or wrongly, there has been a perception from those of us, I guess, associated with zoos that captive breeding has not been a priority, at least on the state government's agenda in terms of conservation. Given this reticence, it was a welcome surprise to us to discover that one of the recommended actions stated in the Koala Expert Panel report was to integrate zoo-based koala populations more explicitly into the management of wild koala populations in South East Queensland, particularly in urban areas. This recommendation aligned well with what we are proposing in the Live Koala Genome Bank concept. The current threats to koalas in urban South East Queensland have been well defined and centre around habitat fragmentation, but typically present in terms of disease, dog attack, and car-related deaths. Habitat fragmentation also results in physical barriers that prevent gene flow and ultimately may lead to inbreeding depression. With increasing habitat fragmentation, our landscapes are becoming more and more landlocked, resulting in what is essentially small captive populations that, in order to survive, may need to be carefully managed. Zoos have a great tradition in managing small populations in captivity and therefore have a skill set to facilitate this type of management. Traditionally, zoos have played a role in conservation by providing physical space and the breeding of endangered species and serving as insurance populations. They also provide support and practical involvement with in situ conservation projects, educational programs, run campaigns to present conservation messages to the public, and allow researchers like myself to access animals for fundamental and applied research. The facial tumour disease crisis in the Tasmanian devil has served as an excellent example of how the Australian zoo community can work in cooperation with government and scientists to establish sustainable captive populations of disease-free animals that have now become ARC populations. It is also fair to say that most zoos and wildlife parks in South East Queensland are already involved with koala conservation to some extent, either in the form of public education, providing koala experiences which develop conservation empathy, providing access to animals and funding for research, or in providing veterinary hospital and rehabilitation services for sick and injured koalas. A bank is a facility in which currency can be securely stored and where deposits can be lodged and withdrawals made for responsible financial management. The concept of a seed or a genome bank has been well established in science, but is usually associated with frozen storage of genetic materials in the form of sperm, oocyte embryos, DNA, fibroblasts, or in the future even stem cells. The concept of a frozen zoo or a genome resource bank for wildlife is also well known, but its practical application has been somewhat limited to just a handful of high-profile exotic species, typically those with similar reproductive biology to humans or domestic animals. The use of frozen thawed gametes in marsupial species like the koala is further complicated by the somewhat unique structure and the composition of their gametes. For example, while we've been successful in producing koala pouch young by means of artificial insemination using fresh and chilled semen, production of pouch young using frozen thawed semen has thus far eluded us. While such technicalities are there to be solved, in the meantime, we've, in addition, chosen to develop a different genome banking strategy In the living koala genome bank, we are using semen from live koalas to make deposits into live female koalas so that important genetic information can be secured. In this scenario, the koala is both the depositor and the physical bank in which the investment is made. To extend the banking analogy further, we're also using molecular genetics or genetic analysis to facilitate wise investment choices and vaccine technology to not only safeguard our physical bank, but to ensure that our genetic investments are protected from disease. The koala is an ideal model for the establishment of a live koala genome bank, not only because of its iconic status, but because there is already significant public awareness over its conservation plight. The koala also commands serious political capital. There are more koalas in captivity in zoos in South East Queensland than anywhere else in the world. And surprising to most people is the fact that the koala also represents an ideal experimental animal, as it can be readily maintained in captivity with well-defined husbandry and breeding protocols. Although feeding koalas can be costly and time-consuming, the species habituates well into the zoo environment and is able to tolerate human presence. They are also an ideal size and temperament for simple veterinary procedures without the need for anaesthesia, such as venipuncture and artificial insemination. Compared to most marsupial species, we also have an excellent understanding of their reproductive biology. The fact that the koala has an overt and prolonged behavioural estrus and that ovulation is only induced after mating means that we are able to use these phenomena to readily identify estrus in the female and to utilise procedures such as artificial insemination. In fact, breeding protocols in the captive koala are now routine and essentially similar to that applied to farm animals. More recently, we're also seeing significant progress in our understanding of koala disease and genetics, all of which facilitates small population management. In late 2016, we were successful in obtaining an ACWID grant to explore the concept of the live koala genome bank. This scheme is not a traditional scientific research grant per se, but was designed to foster and embed scientists into industry for the purposes of implementing collaborative research and development. Our industry partner was the Dreamworld Wildlife Foundation, while UQ and QUT provided the scientific expertise. Proposed as a pilot study, we commenced to implement 3 key components in establishing the live koala genome bank. These included reproduction and genetic management skills from UQ and the chlamydia vaccine technology via experts from QUT. Dreamworld provided the infrastructure and the staff associated with the off-exhibit koala breeding centre and an integrated research and teaching lab known as the Future Lab. The Future Lab was to be the interface between koala scientists and Dreamworld patrons and student groups. At the commencement of our grant, we had estimated that there were over 300 captive koalas housed in South East Queensland wildlife parks, many of which could be immediately drafted into a coordinated network of the living genome bank. Following genetic analysis and disease testing, these koalas would represent the nucleus of the live koala genome bank, in which genetics from threatened populations, wild populations, might be secured. Although our pilot study was initially conducted at Dreamworld on the Gold Coast koala populations, it was envisaged that other wildlife parks would come on board following proof of concept, so that they in turn might also be responsible for other local metapopulations of koalas. The live koala genome bank had 3 primary aims: to determine whether zoo-based captive populations could be used to preserve representative genetic diversity of local wild metapopulations, to establish an off-exhibit koala breeding centre to facilitate genetic exchange and rescue of fragmented wild koala populations, and to integrate ongoing koala research with teaching and learning activity by the establishment of the Future Lab. This slide, containing early concept drawings, gives you a feel, at least, for the scope and the scale of what was proposed in this $3.2 million Future Lab facility. An important aim of the bank was the conservation and storage of local wild genetics into the captive population in order to ultimately establish it as a representation of the regional wild population. The effective vaccination of offspring born from this process would then secure future populations from chlamydiosis. Such a concept would in addition also ensure the genetic welfare of the captive colony, thereby also providing a degree of security and long-term survivability for the koala tourism industry. As koala habitat becomes increasingly fragmented and koala numbers continue to decline, perhaps it is now time to consider a more hands-on, intensive management strategy for koala conservation, particularly in the southeast corner. What we proposed as a new paradigm revolved around the genetic exchange and the functioning of live genome bank practically delivered via a koala breeding centre. We envisaged the live koala genome bank providing at least 4 key genetic benefits to wild koala management that we term genetic conductivity, genetic capture, genetic rescue, and for the sake of alliteration, genetic propagation. Unfortunately, I don't have time to discuss these benefits in detail today, but I can refer you to our grant final report for more information. Before I outline some of the successes of our pilot, it is also important to briefly highlight some of the challenges we faced in its implementation. The first of these we have called industry partner challenges. Just as we were about to start the project, came the terrible news of the Dreamworld Thunder River Rapids tragedy. Understandably, this resulted in major shockwaves throughout the Dreamworld community and the general public, particularly as it was continually reinforced by unrelenting negative media coverage, all of which, for us at least, impacted as a project postponement. Following the accident, there was a change in the Dreamworld senior executive, and this, along with compounding financial concerns associated with the period of park closure, led to the death knell, unfortunately, of FutureLab version 1. Not to be deterred, Al Mucci, along with his tourism Gold Coast colleagues, applied for the state government for its tourism grant of $2.7 million in another attempt to support the FutureLab. In 2019, Al received news that this grant had been successful. The budget was then later topped up with an additional $0.5 million from the state government to breathe life back into the FutureLab proposal. Things moved relatively slowly along 2019 until March 2020, when COVID-19 hit home in Australia. The resulting disruption of COVID saw Dreamworld once again experience long periods of park closure, more financial stress, and the final abandonment of FutureLab version 2. The second series of challenges we have termed legislative. This involved repeated attempts at trying to establish a koala captive breeding agreement at Dreamworld, and confusion over whether or not various components of our proposal required scientific purposes permit or fell under the CBA legislation. Even our own animal ethics committees slowed our rate of progress in what were essentially philosophical issues. The next series of challenges we refer to as political, but these might equally come under the banner of philosophical challenges. In dealing with both state and local governments, we sensed the reluctance to our proposal, presumably on the basis that they saw the live koala genome bank as a legal loophole for zoos to introduce new genetics into their captive populations. This notion appeared to be fed from a perceived anti-captive breeding philosophy apparent in some senior bureaucrats within DES at the time. Added to this frustration was a revolving door of DES staff change that resulted in broken communication, a need for us to constantly retell or reconvince DES officials of the project's benefits. In this slide, we've deliberately referred to Perth Zoo as a shining example of a publicly funded zoo who, on the face of it at least, appears to work well in collaboration with their relative state departments to produce excellent conservation outcomes. Apart from Currumbin Wildlife Sanctuary and David Fleay Sanctuary, zoos in Queensland are essentially privately owned. Is it possible that this management has prevented a closer working relationship of zoos with government and perhaps resulted in an element of distrust in maintaining the perceived balance between respective commercial and conservation interests? We also came across concerns from some in the koala conservation community that what we were proposing was putting at risk some more traditional in situ conservation strategies of habitat management, such that land developers might cynically attempt to utilise our ideas to justify the removal of koalas from their proposed developmental sites. Let us state here quite clearly and unequivocally that the koala genome bank was designed to work in concert with traditional koala habitat conservation. We view it as a tool for management purposes, not a conservation end in itself. Another significant issue was the acquisition of suitable animals for the live koala genome bank. A significant proportion of the koalas for the genome bank in the early days of its operation were suffering from chlamydiosis or neurological conditions and were subsequently euthanized even before entering the program. Finding clean, disease-free, healthy wild female koalas was a major challenge. Other koalas, typically males, had active disease and required a period of treatment before being allowed to enter the breeding program. This often meant extended periods of quarantine and longer periods of captivity. I obviously don't have time to present all our project outcomes in detail in this presentation, but if you're interested in the full details, I can refer you to our final report, which we can email to you as a PDF. Nevertheless, in the short time I have left in this presentation, I would like to provide you with at least a brief summary of our breeding and release data to give you a sense of the potential of the program. Over the 2 years of our active operation, we recorded the following outcomes with respect to our wild-to-wild koala breeding program. A total of 20 koalas were presented, mostly via hospital admissions. 7 of these 20 koalas, all of them females, were euthanized on presentation, mostly associated with chlamydial pathology or neurological symptoms. Of 13 adult koalas that resided in the program, 5 were males and 8 were females. Of these 13, 3 died while in captivity, 1 male from bronchitis, 2 females from neurological causes. Of 8 adult female koalas that resided in captivity, 6 pouch young were produced from 5 dams. Of the 6 pouch young that were produced, 3 survived and are now as sub-adults ready for release. A total of 7 adult koalas have been released, 4 males and 3 females, while 3 adults are still to be released, 2 females and 1 male. Based on the latest advice that we have, all of our released koalas were still alive after 6 months in the wild, and 2 of our males were also opportunistically alive 1 and 3 years, or observed alive 1 and 3 years after release, respectively. With respect to the wild male to captive female natural breeding, 6 pouch young were born to captive females by wild males. 3 of these pouch young unfortunately died in pouch or were lost from the pouch. 3 live pouch young have been incorporated into the collection and are doing well. In terms of the program outcomes, at a pilot level at least, we have shown that it is possible to establish a live koala genome bank in a zoological institution with the help of university expertise. We have demonstrated that we can breed wild-to-wild koalas in a captive breeding facility and release them successfully back into the wild, vaccinated against chlamydia. This, in a sense, is genetic connectivity and genetic capture in action. We have demonstrated that we can breed wild males to captive females. This is genetic capture and the early beginnings of a local genetic repository. We developed disease quarantine protocols and rapid diagnostics, as you've just heard from Lyndall, for facilitating live koala bank logistics. We showed that it was possible to treat male koalas for chlamydiosis and mycoplasma before using them to breed. In a sense, this is a form of genetic rescue. We established a koala breeding program between Dreamworld and DES, a captive breeding agreement between Dreamworld and DES. We have also learned some valuable lessons in this process. These include that in order to make the live koala genome bank workable, we need to be more applicable, or we need to have more applicable and perhaps customized legislation. We can expect to have challenges through the process. The approach that we're proposing is not going to please everybody. There exists the potential also for a much greater applied role for the zoo community and its expertise in Queensland koala conservation. Partner financial stability is crucial for this concept to succeed. This begs the question, do we need a state-funded zoo? Or do we need a purpose-built koala breeding facility to make this concept work? A live koala genome bank needs to run in parallel with habitat preservation and rehabilitation, and as I stressed before, it is not a conservation end in itself. There is also a need for more research in the role of genetic recovery, especially in male koalas, where we had probably more success, and the role and significance of core management in captive populations, which is going to be important, particularly in the future management. Finally, some of you may already be aware that the live koala genome bank concept is catching on in other parts of Australia. based on funding raised from bushfire donations, Port Macquarie Koala Hospital, in collaboration with Taronga Zoo and the New South Wales Department of Primary Industries, has recently commenced a wild koala breeding program that looks remarkably similar to our live koala genome bank. Thank you for your attention.
Thanks very much, Steve. I think everyone will applaud the fact that you've persisted given both the science challenges you've had, but also some of the other challenges that you faced in terms of the dealing with government bureaucracy and other matters. There's a couple of questions there, some of which I think you've already addressed. A number of people are saying, how can they access copies of your report? I think you've indicated that. So if we can get a copy from you, we can certainly lodge it on our website so that there's either a copy or a link.
Absolutely.
Yep. There was a question here that somebody was asking. I think you made mention of some neurological issues in koalas that resulted in euthanasia.
Yes.
The question was just, what's the cause of those neurological issues that resulted in animals having to be euthanized?
We weren't able to get a definitive diagnosis on those causes in terms of the pathology, but these animals either came to us with ataxia or various forms of ataxia. We had one animal that died in captivity, which we were managing more closely, that died of neurological concerns, and it was an animal that simply was found dead in the morning on the floor. The veterinarian of the enclosure, and there had been some discussion, I think, that previously that perhaps the animal was showing some ataxia prior to that, the day before. So no, I mean, given the number of animals that we had problems with, many of these, of course, are coming in from the hospital as well. It's certainly a concern, and probably it equates in a similar sort of number that we were sort of finding with the chlamydia issues at the beginning, in terms of those female koalas that we couldn't include in our, because they had bursitis, etc. So, okay, thank you. All right, Jeff, does that answer your question to some degree? Maybe not completely.
Apologies for that. Jeff's just dropped out, so I'm back in. Thank you for that. That sums it up pretty well. I've got a couple of questions here regarding have any koala joeys bred in zoos been released back in the wild, and then comments around whether the breeding project's looking at increasing the genetic diversity of the captive koala populations. I think that's been addressed in that there is no simple short answer to this. It's, of course, to succeed in the genome project, of course, you'll want to improve the genetics of the captive population. So it's a two-way stream in that, but it's definitely not, this is definitely not favouring zoos over conservation. This is a thing where we have to work hand in hand to deal with that.
Yes, I think that was a very important point that we wanted to make, Brent, was that it was a dual benefit. It's not necessarily going to favour one or the other, but by doing this process, you solve the other process, you solve the other problem.
Yeah, beautiful. Okay, and as we're coming right to the end, I'll just say thank you very much for that. Greatly appreciated, and I'm sure we'll be seeing more of you in the future.
Thank you very much, Brent.
Thank you very much.
Bye-bye.
Hello again, everyone. Now this is the last session of the day. We've got Professor Peter Timms, and he's going to be speaking on developing a chlamydial vaccine for koalas. So Professor Timms is a professor of microbiology at the University of Sunshine Coast here in Queensland. He's nationally and internationally renowned microbiologist with specific expertise in the area of chlamydia and koala retrovirus. His lab is acknowledged as the leading Australian lab and one of the leading groups internationally working on all aspects of chlamydial interactions. Thank you very much, Professor Timms.
Thanks very much, Brent, and thanks for everybody. I'm going to be representing a group of people, of course, but I'll talk as if we've been leading the work. So just a reminder to begin with that some of the pictures in here might have some images. I just do this as a routine now in case some people don't like some of the photos of koalas with disease. Just reminding people, of course, that there's lots of pressures on koalas, and the main anthropogenic ones, of course, are habitat destruction, bushfires, dog attacks, and roads. But of course, the main non-anthropogenic one is chlamydial disease. Chlamydial disease, of course, causing a couple of different situations in koalas. The most important one, of course, is in female koalas in particular, urogenital tract infections. So the top left-hand side is a ureter abscess, so causing urinary incontinence, resulting in the wetted or wet bottom disease. But they also cause reproductive cysts, which are quite painful to the animals when they urinate, and of course leading to cystitis and eventually reproductive blockages, which results in reduced fertility. In addition, of course, there's ocular infections, not as important and not as common, but nevertheless result in started with reddening or conjunctivitis that in severe cases can result in scar tissue formation and blockage of vision for the animals. This is just a modestly recent update of chlamydial infections across Australia, of course, concentrating a little bit in the Queensland area, first of all. Infections can range from 30% up to 70 or even 80%, and disease, of course, won't be quite as high as the infection level, but nevertheless 20 to 40 to 50% disease is not uncommon, with South East Queensland being a major hotspot for infection and disease, together with northern New South Wales in particular. You'll notice that down in southern parts of Australia, probably 5 or more years ago, people were suggesting that chlamydial infection and disease was virtually non-existent. But as people have done more studies down in those parts of the region, while the levels are not as high, there's certainly more infection and more disease that people recognised before. But nevertheless, South East Queensland in particular, northern New South Wales, a major area for chlamydial infection and disease. So what treatments have we got? Well, we know that antibiotics, chloramphenicol in particular, works. It kills chlamydia. But of course, the problem that we have is that koalas are trying to do two things. The first thing, because of their diet, the eucalypt leaves, their livers are producing lots of extra enzymes that break down the toxins in the leaves. With that, they break down antibiotics such as chloramphenicol. And as a result, we might normally give a single dose of antibiotic. In koalas, we have to give daily doses for weeks on end. And what this results in is the fact that it's going to destroy the gut microbiome, the unique microbiome in the cecum in particular that the koalas need. So the end result is that while some wildlife hospitals can maintain and look after animals treated with antibiotics, it's a pretty tough task. So it's not a good solution to the problem. In the middle there, of course, removing diseased animals is a veterinary option, but really the use of a vaccine is a logical thing that we are trying to achieve right now. So I'm going to give a few examples that relate to COVID, given that everybody knows a little bit about COVID vaccines these days. In the case of chlamydia, the vaccine we're trying to make, of course, has multi-purposes. On the left-hand side, in healthy koalas, the vaccine immunize them and stop them getting infection. This is almost impossible. And the same is true with COVID vaccines. The COVID vaccines don't going to stop you getting infected. In the middle, however, we've got infected animals that otherwise look healthy. We want to both reduce their infection levels to stop transmission, hopefully, but also to prevent them from going on from infection to get clinical disease. And so that would be one of the major goals, or two of the major goals for a vaccine. And finally would be a therapeutic effect. And 5 years ago, I would have said this wasn't possible, but it looks like it might be possible, at least to some degree. And so this is koalas already have clinical disease. Can a vaccine turn that disease around? So our vaccine is going to try and do a number of these things, at least number 2 and 3 in this slide here. So this is just an overview of phases of vaccine development as we're trying to move through, particularly from our koala vaccine point of view. You notice it starts on the left-hand side of the middle there with basic science, and we've been involved in doing that for 10 or 15 years now. Move through phase 1, phase 2, and eventually into phase 3, and potentially even into the registration phase. So just look where we're up to. The first phase, or the basic science, is all about antigen selection, the vaccination route, and the number of doses. Just quickly, lots of research has been done so far leading up to this. We've tried a number of different antigens, but the major outer membrane protein, or the MOP, is clearly the best target. And it's the one we've focused on, and it's the one that the current version of the vaccine targets. You notice in the middle of the slide there's MOP A, F, and G. So a bit like your flu vaccine or indeed your COVID vaccine, koala chlamydia has different strains, and the vaccine, as it currently stands, has 3 of those different strains in it. And these are designed to cover the strains that might be encountered, but they could be expanded if necessary. On the right-hand side, I'll just mention that we were attempting at one point in a trial that's still ongoing, actually, to try and use a synthetic version of the vaccine, but that's probably not going to be as effective. And so we're focusing on a recombinant MOP vaccine that's got 3 different strains in the vaccine. Number of doses, we've worked hard to get the dosing down to a single dose. Working with our Canadian collaborators, we're using a so-called tri-adjuvant is able to result in a single dose. And you'll see that on that graph there, it shows that we've been able to get a single dose vaccination giving much the same result as a booster dose does otherwise. And finally, safety. We've now vaccinated more than 250 koalas with versions of this vaccine. We follow them with a veterinary personnel straight away afterwards and longer term, and we see no adverse events whatsoever. In fact, this little study on the screen actually shows a study that was done quite a while ago in Lone Pine Koala Sanctuary, which actually showed that vaccinating even healthy animals not only did have no negative effects, it maybe even had a positive effect generically. So having moved through that, I'm not going to spend too much time on here because there's lots of research done in this area, but the idea of immunogenicity. We know that in the case of koala chlamydia, we want an antibody response, but we also want a cellular response. And while we don't fully understand this, we're pretty happy that we have a pretty good idea about what sort of immune response we want. And so the vaccine we've been able to give the koalas, by and large, gives that sort of immune response, which should be protective. But as we say, the most important part of all of this is protection. Does the vaccine not only be safe and give an immune response, does it protect the animals? We've done a couple of large field studies here, and here we're relying on the fact that animals walking around in their trees are likely to get infections, and so does the vaccine protect against them? And this particular one is done, one of the ones that was done in the Moreton Bay region of Queensland. So in this case, we vaccinated animals, and then we went back 6 months later to see what their disease status was, but also in this particular case, what their infection levels were. So on the left-hand side, at 0 and 6 months, these are the non-vaccinated animals. So you can see that the line in the middle of those bars tells you where their infection level is. And then after vaccination, in the 20 to 30 animals that were in the site, after 6 months, the infection levels had reduced all the way down to close to 0. So what that means in this particular study is that in the ocular case, we were able to get decreased infection loads in these vaccinated animals. In a separate study, now using the single dose vaccination with the 3 MOP vaccine that I mentioned to you, here I've just summarized it down to simply whether or not on the left-hand side, these are the unvaccinated animals. So some of these unvaccinated animals 6 months later ended up with more chlamydia, as in they weren't able to reduce their chlamydia levels. And so you can see that 5 of them actually ended up with more chlamydia. One by chance not. Whereas on the right-hand side of the slide, these are the vaccinated animals. None of them increased their chlamydia. In fact, 7 of them at 7 different sites were able to reduce their chlamydia levels. So again, another field study showing that both ocular and urogenital chlamydial load decreases in vaccinated animals from a single dose formulation. So this is pretty promising from that point of view. Here's another trial again, and we're looking this time about not whether the infection levels decreased, which we just showed you, but also did the disease or progression to the disease decrease. So in this case, there's actually a typo on the left-hand side column, so ignore that for the moment, my apologies. But in unvaccinated animals, 3 of them went on to get disease in the 6 months, whereas by comparison, vaccinated animals, none of them went on to get disease in that 6-month period, showing that basically, therefore, 100% of those vaccinated animals were protected from disease development, so from going on to get disease, sort of thing you're worried about with your COVID vaccine right now. Then we did 2 experiments where we tried to look and see whether or not the vaccine would be able to be effective against animals that already had disease. And the most easy to score one was with ocular disease. So we did this one because of ethical reasons. We withheld antibiotics from these koalas, and we only used animals that were mid-range infections. We didn't get ones that were too severe because that would be unethical. So in this case, we were able to grade them and look at whether or not giving the vaccine, but no antibiotics to these koalas. So when we did that, these are 3 different graphs here. So if you just look at the one on the left-hand side at the top, there's the left eye in green and the right eye in purple. And it was the left eye that had the infection here. And what it shows you is the disease in the eye actually got worse for a couple of weeks, which is what you'd expect. Vaccines don't work in 24 hours. They take a couple of weeks to produce the immune response. But after a couple of weeks, the disease in that eye has reduced. If you look at the 2 graphs below, again, the disease in the eyes of these animals again nicely reducing. I'll just show you the other animals. What it shows you is animals D, E, and F again were reducing their disease. One animal shown in G, animal K7, actually didn't. So it shows you that there are some strains perhaps that are different to the vaccine strain, or in some animals there's some genetic reason. But nevertheless, 6 out of 7 animals, or 85% if you like, were able to revert or cure their infection by vaccination. And this is just pictorial study on the left. That's one of the particular animals in the study with eye infections. And on the right, the same animal that was then released without having to have any antibiotics. So that's a good result. So we're now up to about phase 3. in this study. And so we're trying to work out now how best to take this vaccine, which is clearly highly effective, and make it either more widely available or progress it further along the chain. So how do we do this? I mentioned here the question of how we take the chlamydial research vaccine to a commercial one. So it won't be commercial at the end of the day. We see that the vaccine will be freely available. So on the top here, I've mentioned we will do larger trials, and we'll do that, and some of them are underway, but the point is what we need to do. And also the comment here about whether or not we use a live challenge. That might be what you do in a small animal model. We don't intend to do that because we don't think it's ethical to do that. Instead, these are the steps we're undertaking right now. We're aiming, or we are, producing the vaccine at scale under high quality assurance. Up to now, the vaccine's been a research grade vaccine. Nothing wrong with that. That's good in its own way. We now need to produce it at scale so that we can make it available to potentially thousands of koalas and high quality assurance. To partner with a vaccine company, we've selected a vaccine company who's able to make the vaccine for us. We've had 3 companies that are interested, but we've chosen one. I can't mention what it is yet until we finalize things. And we're also quite keen to take it through registration. So it's good to have a research vaccine, but at the end of the day, we can have it registered with the Australian Veterinary Authority that regulates vaccines. We'll be doing that. So we're well advanced with that. We've been doing that most of this year. In the meantime, however, our plan is to roll the vaccine out in its current format in wildlife hospitals, and I'll just mention that briefly. In Queensland at the Australia Zoo Wildlife Hospital, and you might have seen that we started that trial Friday before last. But also potentially at the Moggill Koala Hospital, Koala Research Rehabilitation Centre, and also the RSPCA Wildlife Hospital. And both of those groups, we've been well advanced with discussions to starting those hopefully in the next 3 months, then eventually into human population. So I'll just show that graphically. Our first ones, as I mentioned, will be at the Australia Zoo Wildlife Hospital. This study will involve 400 koalas, 200 will get the vaccine, and 200 will be controls that don't get the vaccine. We'll look to see over a 12-month period. So this is very much, we're moving now from what you might consider a control trial where we do lots of sampling and lots of laboratory work into one that's a real-world trial. So in this case, we'll be following those animals for the next 12 months. And one of the main measures we'll be having is, do those animals that have been vaccinated compared to those that don't get the vaccine, do they not come back with clinical disease later on? Unfortunately, in Australia Zoo Wildlife Hospital, 15 or sometimes even 20% of the animals return to the hospital with problems. So we're hoping to make sure that those vaccinated animals are not among that group. And then we'll roll it out further with a study with the Moggill Koala Rehabilitation Centre. Again, using the same sort of involvement and endpoint. In parallel to that, we're keen to see as well, not only just in wildlife hospitals, there's an advantage in wildlife hospitals, of course, and that's because there are veterinarians administering the vaccine, the animals are already there, and it's easy, the last step before they're released, to give them the vaccine. But of course, we're interested in wild populations, and we've been talking to groups already that have wild populations that have been radio-collared for other reasons as well, because there's been perhaps a road development or whatever, and to look at vaccinating the entire population. And we're hoping to do one in the Moreton Bay region before too long. We'll vaccinate all the animals in that region and follow them through. Our focus has initially been on Queensland, and you'll see that there, but we're also well underway with discussions in New South Wales groups, and the group at Friends of the Koala and the Lismore population in the Lismore area. 350 koalas a year come there. So we're looking at potentially vaccinating, using our vaccine at that group as well. And finally, I just put a slide up about registration. This is a demanding and painful process in some respects, very detailed, but nevertheless, we feel it's important for the vaccine to be as widely available as possible and to not be just a research vaccine, but to be something that's in a bottle that can be used. And so we are 6 to 9 months through this process, and we're hoping within the next period of time we'll be able to submit an application to the APVMA. They've already looked at our pre-application to hopefully process through to a full approved vaccination at some point. So we have the registration, and as I just mentioned, the rollout to koala care groups, wildlife hospitals, and hopefully wild populations. So we feel that the vaccine is shown that it can be protective, it's safe, and it's useful, and now we're hopefully into a stage where we can make it available both as a vaccine that can be used, but also that can be further evaluated, and that veterinarians can see the value of it firsthand, particularly in Queensland, because that's where we've got starting our work, but hopefully then more broadly across New South Wales and other parts of Australia. So we're not there yet, but we're fairly hopeful that it's going reasonably well. I just want to finish with a large number of groups that have been involved, a lot of students, a lot of people, and a lot of groups that have been supportive of us along this way. So thanks very much for your attention.
Beautiful, thank you very much. Okay, so we might move to some of the questions. It's interesting, a lot of these questions are both management and the science side of things. So we'll begin with, so Vanda's got a question here. Is it possible right now to vaccinate any koala that comes into a wildlife hospital for any reason before release? I mean, yeah, already doing it, but as Professor Tim said, this is very much a case of making sure we know exactly what impacts the vaccine has and how to maximise it. Is that a fair summation?
Yeah, that's fair. As I say, we're starting with these larger wildlife hospitals where there's more veterinary support, and I think just to make sure that there's like we can follow that through, take some more samples if they come back in. But for instance, I know Vanda's group there, a lot of their animals end up at Australia's Zoo wildlife hospitals. We see that perhaps, I don't know, perhaps 6 or 12 months down the road, perhaps veterinary nurses might be in a position, if all goes well, to administer the vaccine. But in this first phase, through wildlife hospitals, and we can just observe them more closely, including we're looking at Mogul as well, of course.
Yep. So Flavia's got a comment saying thank you very much for the presentation. I think a lot of us will agree with that. A comment here regarding are there any wild populations in SE Queensland with vaccinated koalas aside from those in hospitals?
Yeah, well, we are keen to do that. I see it in I guess 3 phases. The first phase is through wildlife hospitals. The second phase is in populations that are already being impacted, and I say because road developments, train developments, whatever, where the animals are already being captured. But the third group, it might be in regions such as Noosa on the Sunshine Coast or whatever, where we know there are declines in populations, where we can perhaps justify that to assist those populations. So I'm becoming more positive about assisted management of some populations that we know are declining, presumably because humans have caused that decline. And in those cases, we might be able to justify vaccinating those populations. But I see that being another year or more away once we've got more confidence with field populations, a bit more longitudinal studies.
So we've got a couple of questions from Anonymous. So one, are there any isolated populations that are chlamydia-free? To my understanding, chlamydia-free populations, as soon as you start to look more closely, we tend to find chlamydia popping up. I don't know of any completely free wild populations in Queensland.
Yeah, I think I agree with your comment that, but perhaps places like Magnetic Island and so on, there might be examples of that. And I think you're right, particularly across other parts of Australia, let alone Queensland, when we thought they were chlamydia-free. Now we're either looking more closely with more sensitive PCR tests or LAMP tests, as we've just heard, or perhaps the disease is becoming more common. I think we're unfortunately seeing examples of that. Populations, and I mentioned a group in New South Wales we're studying with, where not that long ago, 5 to 7 years, they were healthy and had very little chlamydia, and now unfortunately there's more chlamydia present. So it might be the fact that many of the populations we thought were chlamydia-free were not chlamydia-free or increasing. Having said that, if there are chlamydia-free populations, this also gives us a chance to think about vaccination as an additional benefit to helping them resist chlamydia infections, if that may be the case.
I've got another question here. In the phase 3 trials, will the 200 unvaccinated koalas receive antibiotics or other treatments?
Yeah. So the way this trial is being done, it's a very much real-world trial. So the animals will come in and all animals get exact whatever veterinary care is required. Nothing will change in that respect. So if the animals come in with chlamydia, they will get treated, and then half of them will get the vaccine and half of them won't. So it's quite possible or likely that many of them will have got antibiotics anyway. So we don't want to change anything. And we see that for 2 reasons. One is this would be the format then that other hospitals or whatever could use, not changing any other veterinary care, just adding vaccine at the end. And also there's this question about vaccine going on top of antibiotics. We think that's a useful thing to do. We've done one small trial in which that was done, and what it does is the vaccine seems to produce an immune response that is slightly different to the natural infection. which is good because natural infections are not doing a great job at producing immunity anyway. So we see that natural infections treated with antibiotics and then overlaid with vaccine is probably the best way to treat this whole thing. A bit again like your COVID vaccine, sadly.
Yep. Okay, so we've got another question. Once a koala is vaccinated and released, how is it tracked and monitored for disease? Look, there's a number of projects, but as Professor Tim said, there's with the Moreton Bay Rail, I know for a fact those animals were intensely monitored for a range of reasons. And in general, any trial, we're going to be looking closely at those animals and making sure we know the outcome.
Yeah, that's right. We also see an opportunity for community groups and koala care groups to potentially be involved at a much lower level here. But nevertheless, of course, a number of the koalas that come into these hospitals are going to go back with those koala carers, and so they'll be loosely aware of them. Not the same regular monitoring, but nevertheless some sort of community-based involvement. So I think there's different levels going on here, and we see it as a stepwise. But wherever we can, if we can monitor them in longitudinally with radio collars and so on, that'll be great. And I think Australia Zoo Wildlife Hospital actually has a small project to do exactly that. So not every single animal, but a number of them. So yeah, that's exactly right.
Yep. We've got a comment here from Kathleen regarding keeping an eye on seeing the koalas around her are healthy. And that's something that's it's a bit of a challenge in that just looking at a koala, we can't tell whether it does or doesn't carry actually chlamydia. It's only when you see the overt signs, which would be much easier if you have a look. It's really challenging.
Yeah, I agree. And that's why I think it's useful to consider eventually vaccinating all comers or all animals in a population for exactly that sort of reason. I agree.
Yep. So Narelle, he's got a question, and this is a big one. I think we might actually end up providing a written response to this, but in short, while chlamydia was described as the main non-anthropogenic impact, is there evidence of a causal link with stresses from habitat loss, etc., or at least as a known contributor to disease prevalence? Would you like to put, I mean, that's going to be a lot to answer. Would you like us to?
It was a complicated question. I wasn't sure whether there were multiple parts in that.
Yeah. And we've only got 6.5 minutes. Sorry, Narelle, we might actually put a written reply into that because it's a big and complex question.
Yeah.
For that. And I'm going to have to say the same thing too about regarding a question on the existence of chlamydia strains of different pathogenicities.
I think just briefly, sorry.
Yeah, right.
Yeah, briefly there, I think we do see evidence of different strains of pathogenicity. Do we understand it fully? No, I don't think that's true. But nevertheless, I do think there are certainly lots of different strains, and I think that's the case, which is why we've been looking in this particular choice of these three different strains in the vaccine. But we certainly see it possible to add additional strains to the vaccine, particularly in different geographical areas. This is no different to your flu vaccine, your COVID vaccine, your meningococcal vaccine. So the opportunity to add in some additional strains in certain regions is I think, one way of trying to overcome more virulent strains that might be out there. But it's a good question that I don't think we completely understand the answer yet.
Got another question from Flavia regarding basically mutation speed. Does chlamydia mutate as fast as a virus such as COVID, or will the vaccine provide more protection?
Yeah, it's a pretty good question. Scientifically, that's a really interesting question. The mutation rate of chlamydia is slow by comparison to other bacteria. And again, as soon as you get to viruses, the science behind viruses is such that they mutate faster. In fact, some viruses are designed to mutate faster. So chlamydia is less of a risk, if you want to put it that way, from its point of view of mutating outside the vaccine's scope. Having said that, I think, again, we can, I don't think there's going to be a major issue from escape mutants or whatever you might want to consider there, by and large. It's not the same issue you have with viruses.
Thank you. Let's go through there. So we've got Anonymous has asked a question regarding recruiting koala rescue groups to capture unvaccinated koalas and return for disease testing. Generally, we wouldn't be going down that. We the university for a start would never get ethics approval for that. It's very much more rigorous, and we need to make sure that the data we collect is absolutely perfect. So while koala rescue groups play a massive role in identifying and bringing sick koalas in and rehabbing them, their role would be a little bit different if they could provide any support in this side of things.
Yeah, I agree 100% with that. What they might be able to do, nevertheless, if they're aware there's koalas in the area, they can use their camera phones to take photos of them and things like that, and maybe they can send the photos into us, which is somewhere in between recapturing them. But I agree, there's no justification for going through the process of recapturing them. But some photos, some binocular vision, and so on, or cameras these days can do an amazing range of things. Somewhere in between.
And we've got a question here where we can find written responses to questions. That'll be up on the website. We'll have a response on that on the website. Okay, well, look, we're coming to the end. Look, thank you very much. One big takeaway in regards to the vaccine, it's just a beautiful way to show just how complicated koala threats are, and just how spatially and temporally the threat profile changes. Every individual population in space and time has a really different effective threats around it. So it's a very complex situation that I'm sure gives you endless opportunities to ask questions.
Yeah, no, that's exactly right. Some populations have different threats, different strains, different everything. So it's a tailored event. I agree.
Beautiful. All right. Well, thank you very much. Greatly appreciate your time.
Okay. Yeah, happy to be involved. Thanks very much.
Thank you.